All right, this is homework 2, part D. So this one to derive an expression relating to the maximum angular velocity at which a cylindrical container of height h, radius r, and filled to depth b with a fluid of density rho can be spun without the fluid spilling out. So here I've drawn the cylinders. This is the water right here. So these cylinders are going to be dr. Right? These are dr. This one here is dr2, and obviously this is the radius because this is the cylinder on the height h. And this is the top-down view. This is r, and then dr is this circle here. Okay, so we need to write an integral for the volume of the circle. So it's going to be 2 pi r, and then we have the height h, and then dr. As an integral. I'm going to go from 0 to r. And obviously we know h is equal to omega squared times r squared all over 2g. So we can do is we can plug in h into this equation. So rewrite that over here. So omega squared r squared all over 2g, and then dr. Um, all right, so what we can do is we can take out the constants now. So it's going to be pi is a constant, obviously, r, or not r, omega squared is a constant, and g. So what stays in the integral is the r. So it'll be from 0 to r still. And then we have this r and r squared, so it'll be r cubed. Dr. So now we can start to evaluate this. So when you evaluate it, you get obviously 1/4 r to the fourth. So we can pull out that r to the fourth. So it'll be pi omega squared over 4g, and then r to the fourth r to 0. And obviously, you just plug in r to the r, and it'll be big R to the fourth, and 0, 0. So this is going to equal pi omega squared times big R to the fourth all over 4g. And obviously we know that is equal to pi r squared d. I erased some stuff to give myself more space, and now we're gonna solve this for D, so we can cross out this pi. So we'll end up with D is equal to omega squared over r squared, because 2 of the exponents cancel out, and 4g. So now what we can do is we can do d minus omega squared r squared over 4g. So now we're going to add this height, omega squared r squared over 2g, and then all that is equal to h. So now we're going to go one step further and try and solve this. So we'll end up with h minus d is equal to omega squared r squared over 4g. So we're just trying to solve this for omega. So what we're gonna do is we're gonna solve for omega, obviously. So we'll do times 4g. So omega equals 4g times h minus d. And we're gonna have to divide by r squared, but we're also gonna have to square root because this is omega squared, so we'll just write it as r, and then we'll square root the top, and that's the final answer.